Hi guys, in this video we are going to learn how to find an absolute error of a Taylor polynomial. Without wasting of time, let's move on to the session. And also, if you are new to this expert tutor channel, please don't forget to subscribe it. Here we are going to see a question: determine the absolute error when approximating function of x which is equals to sine 0.4 using a third order Taylor polynomial. So here we are going to do a Taylor polynomial for sine 0.4 for third order Taylor polynomial, and also we are going to find an upper bound for that absolute error. So first of all, let's write the Taylor polynomial for the third order sine 0.4. Here you can see for the approximating value, for when we are taking a value, we are going to get as x naught is equal to 0. The reason is 0.4 is very much closer to this 0. That's why we are taking the Taylor polynomial near to point 0. If I write the Taylor polynomial here, function of x, which is going to be equals to f0 x naught to x minus x naught 0, and this is going to be 0 factorial. Likewise, you can write up to third order because they have asked for third order. Now we have already written the third order Taylor polynomial. So now we need to find out the values for these fx naught and f dash x naught and f double dash x naught as well as f triple dash x naught. For that we need to differentiate this sine x function because we have taken that f of x as which is going to be equals to sine x. So that we need to differentiate and substitute the value of x naught here. That x naught is going to be equals to 0 because we have taken the Taylor polynomial which is very closer to x naught is equals to 0. So now let's differentiate f of x first. We are going to get cos x. Likewise, do for others too. We are going to get minus sin x at the same time is equals to minus cos x. Now let's substitute the value because we need to put the value for the x naught for the function and substitute this x naught. So if you substitute this 0, you are going to get, so here you can write it like this, or else you can write it like this. It's going to be sine 0, it's going to be 0. Likewise, f dash x naught, which is going to be 0. So if you substitute 0 over here, you are going to get cos 0, which is equals to 1. Likewise, if you do, you are going to get 0 and is equal to minus 1. Now we have figured out all the values, and if you substitute over here, you are going to make this f0 x naught as it's going to be 0. The reason is this part is 0, so let it mark with another color. So this part is going to be 0. So if you multiply those total part, it's going to become 0. Likewise, this part is also going to become 0. The reason is f double dash x naught is going to be 0. So if you simplify those part, you can directly write it as 0 and this part as 0. You are going to get an equation of f of x which is equals to x minus x cube over 3 factorial. So up to we have get up to third order Taylor polynomial. So now let's substitute the value of 0.4 and get the answer. If you substitute 0.4 over here, you are going to get 0.4 minus 0.4 to the power 3 divided by 3 factorial. Now we can use the calculator to find this value. Now I got the value of 0.38933. So let's see the question again. Determine the absolute error when approximating f of x sine 0.4 using a third order Taylor polynomial. So first question is they are asking about the absolute error from this value. So first of all, we need to understand what's the meaning of absolute error. We have already done a video. If you haven't watched those videos, I have given the link in the description. The video is about what's meant by the absolute error. It's very simple. We are going to take the modulus function, and from the true value of this f of x, the true value, we are going to deduct the f of x of approximate value. So here the f of x is going to be 0.4. We need to find for 0.4. So we need to find out the true value. Here we have already found out this approximated value for 0.4 using third order Taylor polynomial. So now we knew the value for this one, it's going to be 0.38933. Then how we are going to find for this one? For this one, you can directly substitute this 0.4 for this sign, and you need to figure it out the answer using a calculator. So now I'm going to do that. So I have used the calculator and found out this answer. But remember, when you are using the calculator, most probably your calculator will default will have the value for that angle in degree. But here we are substituting the value of radian. Always remember, this is they have given in the radian. So you need to change the angle unit for radian and substitute the value. If you do so, you are going to get an answer. This is going to be the true value, but I have chopped that value up to like 1 2 3 4 5 6 decimal. So what we are going to do next is we need to deduct one from the another, and after that we need to take the modulus of that part. If you do that, you are going to get an answer of 8.8 into the 10 to the power minus 5. This is an absolute error when you are calculating the third order Taylor using sine 0.4 using third order Taylor polynomial. Now the question, another question they have asked is also determine an upper bound for the absolute error. So here we have calculated something 8.8 into 10 to the power minus 5, but without calculating this, without calculating the value of f 0.4, the function of 0.4 approximating value of third order polynomial, we can directly get the error part without calculating this function of 0.4 by approximation function using this for the sin x. Without calculating this, we can directly figure it out the value, the absolute error part. So how we are going to do that? For that one, we need to find the remainder part of this Taylor polynomial. Normally when you are using the Taylor polynomial, we are going to approximate like this: function of x is going to be equals to Taylor polynomial of that function plus some remainder. So here we have found out this, and after that we knew this one f of x by using the calculator. We have found that, and by deducting that one we found out the answer, the absolute error. But now what we are going to do is, without finding these two, we can directly substitute the value over here, and we can find what's the error we are going to get, what's the maximum error, or what's the range of that error we are going to get during the approximation using a third order Taylor polynomial. So for that you need to know the equation. So let me write it over here. So Rnx is going to be equals to f n plus 1. If you are getting an order of nth order Taylor polynomial, it's going to be f n plus 1 into the function of f. You need to derivative up to the order of n plus 1, and x minus x naught n plus 1 divided by n plus 1 factorial. So now we have figured it out, but remember this is not going to be x, it's going to be epsilon x, which is going to be another function or another value which is going to lie between 0, the value we have taken at the initial point, the approximation value we have taken as 0 initial point, and also it can be either 0.4. The epsilon x is a value which is going to lie between 0 and the value we are substituting in that equation, which is 0.4. So this is the range, and here the x, you need to put this x. So we already took this x, we are going to calculate for 0.4, so you can directly substitute that. 0.4 minus x naught, we already knew that it's going to be 0 and n plus 1 divided by n plus 1 factorial. So this is the error part we are going to get. So the error of this Taylor polynomial is going to lie between, it's depend on this epsilon x, it's going to be a value between 0 to 0.4, but actually we don't know what's the value of epsilon x in the beginning. But if you want, you can actually If you know this value 8.8 into 10 to the power minus 5, it's going to be equals to the Rn x. So you can substitute and get the value of epsilon x. But here they have asked about the maximum value of that absolute error. They are not asking about the accurate value. If you want accurate value, you need to follow this step. You can get the accurate value. But here we are going to get the range and we need to check the maximum absolute error we are going to get. So how we can do is, so if you want the n, the Taylor polynomial n we have taken is, n is going to be 3. The third order we have taken, so it's going to be 0.4 into 4 divided by, if you substitute 3 over here, you are going to get 4 factorial, and it's purely dependent on fn plus 1, the value of epsilon x. So let's substitute the value again. So it's going to be 0.4 to the power 4 fn plus 1, which means you need to differentiate the function f3x. Actually, we have already done that. F3x is going to be equals to minus cos x. So it's going to be minus cos x. If you differentiate again, you are going to get f4x, which is going to be minus. And if you differentiate minus cos x, you are going to get minus sin x into minus, which is going to be plus sin x again. So sin, instead of x, here we are using a value called epsilon x. So let's mark that as epsilon x divided by 4 factorial. So to find out the maximum value of this, so what we can do is, anyhow these are going to be a fixed value, so it purely depends on how this epsilon x works. If this epsilon x increases, we actually knew that sine value will be increased from 0, because up to 0 to pi by 2 radius, it's going to increase, the sine is going to be increasing. So what you can do is, up to 0.4 we can tell it's going to be increased. So the maximum value of sine epsilon x within the range, the epsilon x we knew the range, it's going to be 0 to 0.4. So the maximum value of sine epsilon x will be happening when sine epsilon x is equal to sine 0.4. But actually we knew the value of sine 0.4. We have calculated that true value here. It's going to be 0.389418. 0.389 the value. So let's mark the 9148, I think. So now what we can do is, you can directly substitute the value over here. You are going to get 0.4 to the power 4 factorial into 0.389148, and let's use the calculator now. If you use this value, if you use the calculator to solve this, you are going to get 4.15 into 10 to the power minus 4. So this is the value. Remember, this is the maximum absolute error which can happen when you are calculating the value using the third order Taylor polynomial for sine 0.4. So this is the maximum value. If you want, you can check whether this is the a higher value than the actual error. So if you want, we have already calculated that absolute error before. So here you can find 8.8 into 10 to the power minus 5. So this is the absolute error, the true 8.8 into 10 to the power 5 minus 5. We knew actually it's going to be less than the maximum absolute error. So this test passed. So I hope you have understood it clearly. If you have any doubts, please comment it below. Thank you for watching.